So if I were in front of a class, I would ask you guys what happens when you try and take the square root of a negative with your calculator. So if you want to take a second to do that, what ends up happening is your calculator will give you an error message. Why do we get an error message when we try and take the square root of a negative? Think about what the square root means. So the square root of 16 is positive or negative 4 because 4 squared or negative 4 squared equals 16. A number times itself equals what's under the radical. Is there a number that we can multiply by itself that will give us a negative value? And the answer is no, because you have to take a positive times a negative in order to get a negative answer, and that's not multiplying it by itself. So a little bit of vocab. An imaginary number is the square root of negative 1, and we represent that with the symbol I. Some examples of real numbers are like 1/2, 0, square root of 5, numbers that you've been working with your whole life. Imaginary numbers all involve I or a negative under the radical. So there are some examples. All right, so we can simplify with imaginary numbers. So if I have the square root of negative 6, just like when I simplify with a regular radical, I can split this up as the square root of negative 1 times the square root of positive 6. We can't simplify the square root of 6 like we would normally do. There's no perfect square factor. I turn square root of negative 1 into I, and then leave the square root of 6 alone. If I were simplifying the square root of negative 8, again, I simplify out or pull out the square root of negative 1. 8 does have a perfect square factor, so I can split up the square root of 8 as the square root of 4 times the square root of 2. And then I get the square root of 4 is 2. I'm kind of doing this in backwards order. The square root of negative 1 is I, and then times the square root of 2. So that's how we would simplify with imaginary numbers. So like we saw on Friday's lesson, the in-class assignment for Friday, we looked at the discriminant of the quadratic formula to determine how many solutions we had. If we ended up with a negative value under the square root, the b squared minus 4ac, it had 0 solutions, 0 real solutions. It would still have 2 imaginary solutions. So that's the next example we're going to take a look at. If I've got x squared equals negative 81, to solve that, I would take the square root of both sides. Sorry, my calibration is off, so this isn't going to be a real pretty lesson today. So I've got x equals the square root of negative 81, and I can simplify that just like we saw simplifying the square root of a negative. The square root of 81 is 9. Actually, we should have our plus or minus here. And the square root of negative 1 is I. So the two solutions for x squared equals negative 81 are x equals positive 9i and x equals negative 9i. Our second example here, I've got 5x squared plus 90 equals 0, so I'm going to solve this by undoing, subtracting 90 from both sides. Subtracting 90 from both sides, so I get negative 90, dividing both sides by 5. So we get x squared equals negative 18, and then when I take the square root of both sides, I get positive or negative square root of negative 18. So again, I'm going to go ahead and simplify that. The perfect square factor of negative 18 is 9. I'm going to put this in order this time, and then I'm going to pull out that square root of negative 1, and then 9 times 2 is 18. So 9 times negative 1 times 2 all gives us back that negative 18. Square root of 9 is 3. Square root of negative 1 is I times the square root of 2. All right, and the last piece is finding the zeros of a function. When we're given a quadratic function, the zeros are where it crosses the x-axis. So when you think about the graph of a quadratic function, or any function, when it crosses the x-axis, that's where our y value is 0, or our function is 0. So I'm going to replace g of x with 0. And the first thing that I think about when I'm solving a quadratic equation is, does it factor? Are there any numbers that multiply to 12 and add to 4? Well, 12 times 1 is 12, but that adds to 13. 6 times 2 is 12, but that adds to 8. And 3 times 4 is 12, but that adds to 7. So this one doesn't factor. I could complete the square, but I prefer working with the quadratic formula. So I'm going to set that up. The coefficient of x squared is 1. The coefficient of x is 4. And our constant is 12. So we've got the opposite of 4 plus or minus the square root of 4 squared, or b squared, minus 2 times a times c, all over 2a. So the next piece, I'm going to simplify what's under the radical. 4 squared gives me 16. 2 times 12 gives me 24. 2 times 1 gives me 2. And let's see if I can move this. That's all attached. So I will have to work on to the side here. We've got 16 minus 24 is negative 8. And as we saw before, we simplified the square root of negative 8 in one of the earlier slides. It's simplified to 2i times the square root of 2. And if you think about that, remember the perfect square factor of 8 is 4. Square root of 4 is 2. So that's where this 2 came from. And then the square root of the negative 1 is I. And then the 4 times 2, we had that square root of 2 left over. What I'm going to do now is simplify this. Because there's that plus or minus sign, I have to divide each piece by 2. If your algebra teacher uses the butterfly method, that's kind of what it looks like. So the negative 4 divided by 2 gives me a negative 2. I've got my plus or minus symbol. And then when you divide, remember this is like one of the review skills warm-ups we've been doing, that second one. When you divide a radical with a coefficient, you just divide the coefficient. So I am canceling these 2's, leaving me with I times the square root of 2. Alright, our second example and last example for this lesson. Again, we're solving for the zeros, so we substitute 0 for the function. And because I already know what happens, this one doesn't factor either. This would be the AC method. So we would do the 2 times 5 if we were going to factor it, which is 10. And there are no numbers that multiply to 10 and add to x. So again, I'm going to use quadratic formula. Sorry about the messiness. We've got our a is 2, coefficient of x is 1, and our constant is 5. So we've got x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Alright, so simplifying under the radical, 1 squared of course is 1, 4 times 2 is 8, times 5 is 40, and 2 times 2 is 4. 1 minus 40 is negative 39. 39 has no perfect square factors, so we have nothing to factor out except for the negative. So the square root of negative 1 is I, all over 4. All right, hope you guys have a great weekend. I'll see you on Monday.